So guys, when I think about any of these pies or anything, whatever, just read it as it is. So now I can say 7 pi over 6. You know exactly how to count this. You go like this. Here's your 2 pi. Here's your pi. Well, you know this guy and this guy, if I took the 6th pi slice of 6, I know it's going to be here. So what's one more pi slice of 6? Right there, this guy. So there's another pi over 6 value, but it's the 7th pi slice of 6. That's the way I read this. Pretty simple, right? So you can take this for any of the values. If you're doing trig, like one of the odder but more common ones you're going to see is like the pi over 12. So when we're talking about like angles and whatever, the pi over 6, if you're learning this, which I might do another YouTube video on, this is my 30-degree angle. But if I were to divide all of this pi into like 12 pieces, right, I'm going to get the 12th pi slice of 12 over here is going to equal pi. So this guy over here is going to equal pi. So this is going to be 24 pi over 12 to reduce down to 2 pi. So I'm just going to count all of these slices all the way around, which I'm not going to do, okay? But you'll understand that eventually this is 15 degrees, very simply stated. But if I were to ever actually just ask you what the radian value is, not memorize it, not remember it, no, you just learn it and you kind of understand what it means or what it's doing or what's going on. We're not putting it in degrees, we're putting it in radians. That's what the whole point of the circle is. So if I were to tell you 16 pi over 12, well, you know that this guy is 12 pi over 12. That's going to reduce down to my pi. So I need, what, 4 more slices of 6, or 12, sorry. So I need like 1, 2, 3, 4. So it's going to be like somewhere around here. And then 5, and then 6. So, but we know that this guy is going to reduce down to the same thing that it was, is 3 pi over 2, right? Because that's the 3rd pi slice of this guy. 1, 2, cancels, and this is the 3rd pi slice of 2, right? So if I were to tell you 16 pi over 2, that means, so this is 12th, this is the 13th, this is the 14th, this is the 15th, this is the 16th pi slice over 2, and obviously that would reduce down to something like 3. That's what is that? That's your 4 pi over 3, right? Eventually when it reduces down. So don't think about or remember, you learn this. So learn what it actually means, like what we're doing mathematically, which teachers are not going to tell you at all. This is the really simple breakdown of how to actually understand radian degrees and like how to factor them or look what they're actually doing and how they're moving around the circle. Because much unlike, degrees, we've learned that since we were little. Your mom's like, oh, make a 90-degree angle left and turn at the tree or whatever. And it's like, okay, like I know what a 90 degree is, Mom, or a 45 or whatever, 60 degrees, you can roughly guess. But that's all we're doing. We just don't know radians that well. So this is how you actually learn this a little bit easier, is to just say it's this many pi slices and this is how many pi slices we're doing it out of. So no matter what value, no matter what value I give you for out of 2, or I say 11 pi over 6, or 7 pi over 3, it doesn't even matter what value. These don't look so intimidating anymore as far as like what angles they are or what they mean. Obviously this reduces down to 2 pi. So I know that this is over here if I were to draw a circle. I know that guy's right there. I know this is 11 pi over 6. Well, if I doubled this pi slice, it would be 12, which would be this over here. So it's actually right here. So it's all the 11th pi slice over 6 is right there, which makes sense because the first pi slice of 6 is right here. So if I were to go all the way around and slice this up, boom, 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 I'm going to get the 11th pi slice over 6 over here, which makes sense because I'm just minusing 1 pi slice, which gives me 11 pi over 6, right? Or this value of 7 pi over 3. I don't even know what this is. I don't have to even know. I can literally count this out. 1, 2, 3, 4, 5, 6, 7. Okay, well, we know that this is the third pi. It's still saying the same thing. It's the third pi slice. So it's very, very easy. So this doesn't have to be intimidating, which makes a ton of sense because this here, 6 pi over 3 reduces down to that 2 pi. So we're only going up one more third pi slice. So, which makes sense because 6 pi plus pi, 3, and 3, basic math, you can add because there's a common denominator. So you can just add this, which equals your guy that you have right here. So no matter what, you can always know how far it's going around. Like if I said 424 degree angle, how many times did I go around the circle? Well, we all know that 360, it goes around like once. So we know that we went around once. So same thing with radians is we're not actually changing what we're learning. We're just actually learning it differently. And I'm trying to teach you the way to learn. So forget all of this other stuff because it gets just really confusing. Like, I don't even know how someone like computes some of this stuff. I know that's actually talking about cosine, sine, but that's another video, and I'm doing that. That one should be the previous one that you look at, but you can also look at this one and get some value out of it. Okay, so this is more so like what we're looking at, and it's just a little bit neater. So all I'm going to do is kind of help this go around, and this should clarify everything what we talked about. So this is obviously our first pi slice over 6. This is our first pi slice over 4. This is the first pi slice out of 3. So those don't change. Those never change. Those are always the same. Okay? And these are our third pi slices and our fourth pi slices. So we already know that this is a pi slice, this is a pi slice, right? So we know how to slice these pies already, so that's really easy. Now all we have to do is say this is the second pi slice, because everything else we reduce down. So if it's not the same pi slice, like this 6 and this 6 is the same, then it's going to reduce down to something else. Or the 4 or the 4, or the 3 or the 3, or the 2 or the 2, right? So all this stuff's going to reduce down to whatever it is. So don't worry too much about that. So this is the second pi slice of 3. This is the 1, 2, third pi slice of 4. This is the 5th pi slice of 6 here. This is pi, which will always reduce down. So you guys should be able to easily fill in the rest of this stuff here, which we will go over. But let me kind of draw it in. So what do we have? Okay, well, this looks familiar because we're having, so we know that this is a 6 pi slice, and we know that this is a 6 pi slice, but we have no idea on what number that is. We know that this is our 4 pi slices. We know that this is our 4 pi slices. We know that this is one of our third pi slices when we divide everything by 3. Boom, boom, boom. So now it's just a matter of counting, like which one is it? So let's do the 2s, or let's do the 3s, excuse me. So, okay, second pie slice. So this is the third pie slice right here. So don't forget this guy. Don't forget pie, because it's inclusive, right? So I'm going to go another third, which is the next one, just happens to be here. So this is my fourth slice. This is my fifth slice. Ooh, look at that. 5. And then this is my sixth pie slice over here, which ends up being the same thing, right? So now let's count our 6s, or let's do our 4s. So I got our first one here, our second one's at the top here, our third one's here, fourth one's out on the side here, and this one's our fifth one. And this one's our sixth one, this guy down here, and here's our seventh one. Great. So now I know those two, 5 and 7. So I'm not actually memorizing or whatever. I'm knowing what these are, guys. I'm knowing what these are. That's the easy part about it. Once you understand this and learn this, it's easy. Then this doesn't become a memorization thing, which your teacher's probably telling you, which is completely wrong. So if I do all the rest of these and I do this for pi, I know that this is the 6th pie slice, so this one's the 7th, easy. And when I count these all out, this one's the 11th one. And when I count, oh, well, I got these 2s. I forgot these 2s right here. So the pie slice is over 2. Well, this one reduces down. That's the 3rd pie slice of 2. So that's the unit circle, and I didn't have to memorize a thing. I just have to know how many slices I'm cutting into and how to like actually just count them all the way around. And that only takes like 5 seconds. That's as good as memorizing, or that's as good as whatever they want to call it, or your teachers want to call it. Memorizing or remember. Oh. It's like, I don't remember. I'm taking 15 credits. I'm taking 17 credits. I don't have time to remember or memorize things, right? We're memorizing too much. So as college students, we can look at these values just completely different, and it's going to make your life so much easier going forward in trigonometry, and I hope this really helps. Subscribe or like or share to math teachers or students that are struggling. I'm usually in the math lab trying to help students when I'm not trying to learn myself trig, but this really, really helped me is to read this completely different, and I hope this helped you. Please share. Thanks.